Good evening, everybody, and welcome to another PASS Start Prof Pipe Modeling Stress Analysis Training. I'm your anchor, Additional. Kindly subscribe to our YouTube channel if you have not done so. Search for AIGE Limited on YouTube and subscribe to enjoy videos and similar to this, because if you miss any session, you might have missed a lot. So today we are going to be modeling the pipe that we can see on my dashboard using Start Prof, and we are going to run pipe stress analysis on the same. Okay, so let me move over to the Start Prof software. So the first thing you do is to click on New, or you can either click on File, either way. So you click on New, then you're going to see New Project, highlight piping, and click OK. All right, so you are going to see the first dashboard. In this place, click on Process Piping. And once you click on Process Piping, automatically the stress analysis code shows as ASME B31.12, version 14. So all the codes as applicable to process piping for the year 2014 has been installed in Start Prof. All right, and you can see it's showing today's date being 31st of July 2020. So description, we can save this particular piping. So we can save it as practice 1. All right. Then once that is done, you can click on additional. Additional here shows you the different type of spring constants that we have. So we have variable, we have constant, you can change it. All these are standard springs. Then we have mode of spring selection. We leave it as operation. Next, we have seismic load. In Nigeria, we don't have seismic, so we leave it as don't apply seismic. All right. Then next, we have wind, ice, and snow. This is applicable for those in Europe. For here, we don't have snow, we don't have ice, and we don't have wind. Then we have other constraints. In this place, we have the anchor coefficient as 1. All right, the piping size specification is ANSI, and the insulation type is also highlighted here. So we leave all these as constant. Okay, under additional, you don't do anything, but it's just telling you that you have variable, spring type, and constant, and they are there. Okay, the different types. If you click on the drop down, you will see it. So we'll go back to general. Then ambient temperature. Our ambient temperature in Nigeria is 23 degrees. Our service life is 20 years. Our test state is water, and our test temperature is, let's make it 40. Then we'll click OK. So immediately you click OK, the first thing you see is your node. So you have your node 1. Then from here, we can build our piping. Go to the upper right corner, you will see this logo, insert pipe, the very first one there. You click on it, and you will see the node. So it says start node is 1, end node is 2. So from here, we'll click node 1 to 2. And once that is done, you're going to see this interface. So we have this interface, all right? And this is where we are going to model our pipeline from. So from last class, I spoke about pipe length, the X, the Y, the Z, all right? And that is correlating to the coordinates that we have on X, Y, and Z as displayed here. So in this case, we want to build our piping on the X, all right? So I can say this is 1,000 or 10,000 millimeters, okay? Then it's asking for my outer diameter. Let's make the outer diameter 200. Wall thickness, it doesn't matter. I'm even going to change this to meter after I finish uploading, okay? So you just do the direct conversion depending on what you have. So my wall thickness is 15, mil tolerance is 12.5, corrosion allowance, I leave it as 2. Then the material, okay? Anytime you are modeling, you'll be given this code, or you will be given the particular material and you'll be expected to determine the code. So if you should put this code on the internet, it will display the material type. In this case, I'll just pick A135B. My test pressure, let me leave it as 15. Temperature we've said is 23 degrees. Test pressure. So test pressure will be a little bit higher than the working pressure as a standard. And I like using 1.5. So 1.5 of 15 will be 22.5. All right, then my insulation, you have different type of insulation. Okay, you have wool with aluminum sheet, asbestos, and so have you. So I'll just pick on one, I click OK. Then for the fluid, you don't need to worry about the fluid, just get out the fluid density. And in this case, I put it as 1,000. Yep. Piping, come here to your upper right. Look at the screen. Then click OK. Once you click OK, you have this. So we have put in the design for our piping system. Anyone, depending on the installation type you want to use. Okay? But that will either be given to you during the design stage, or as a design engineer, you have to define that and also state it while designing. All right? So once you do that, you click on your two ends and you put an anchor, because your pipe cannot just be free in the air. So the anchor will be like the end support. So we have an anchor here, and also we have an anchor at the other end. For fluid, no, go to density. I put 1,000, meaning water. So it will populate the fluid itself. Yes. All right. All right. So at this point, I can go to File, go to Custom Units, and I change my length from millimeter to meters. I'll do the same thing also with my thickness, then area to square per meter, moments to meter raised to power 4. Then my stress, I change it to megapascal. Yep. So maybe the length you choose is too long. Click on the line in between, double click on it, then shorten the the length of the pipe you used. You know, you are working in meters, you shouldn't put 1,000. Since you're in meters, you should put like 10. All right. So now if I double click, you can see my meters are turned to 10. I can make this 100, let's make it 50. Then my outer diameter is fine at 2. Then there we have it. All right. So the next thing I want to do, yes. What did you put there? 10 meters. Okay, don't worry. I will troubleshoot it later. Let's finish with the one I'm going about now. So next thing I want to do now is to add a node at the center of my pipeline. So this is the node. I click on the node and I click on my pipeline, and it's showing me insert a new node along the pipe at specific distance. In this case, I want to make the node to be at the middle. So I click on middle here and I click OK. So once that is done, you will see that I have a 0.3 at the middle of my pipeline. So at that node, I can now impute what I call the expansion loop. The essence of the expansion loop is to help the pipe to dissipate stress while in action, so as to avoid deformation. So I will click on, this is the symbol here, expansion loop. So for the length, I put 2. Here I make it 2. Then leg angle, I make it a 90, and I click OK. So once that is done, you can see that I now have an expansion loop. So let me zoom in on that section. So this is my expansion loop. And you can see that the end of the expansion loop is open. So I have to put a bend, all right? An elbow, so as to cover those ends. So I click on my elbow. So here you have your elbow defined. I'll just come here and say short elbow and click OK. So there I have my elbow. Once I have one elbow, I can copy and paste that elbow to the other end. So I say Control C, then I click on my other nodes, 5, 4, and 6, and I say Control V. So there I have it. So if I zoom to extent, I have that. All right. Next thing I want to do now is to run analysis. So I go to run analysis, and it says save changes to start 1. I say yes. So I give it a unique name. I can just say 31st07 slash 0720/3, and I say save. So now you say run analysis. Yes, please. This analysis has warning. Go ahead. So now I'm running analysis. Okay. Now I've run analysis on my pipeline. What I want to do now is to check the results. So I can come to the output and go to the 3D view. So let me see how my pipe will behave in a dynamic environment. So if I click on play, you can see my pipe is falling. All right. So there are other things I need to do at this point in time, which is to add support. So I'm going to add support on my pipeline so as to ensure that it doesn't fall freely the way it does. So I'll click on one side of my pipe, right click. Can you all mute your mic? Right click, then go to insert multiple nodes. The number of parts I want here is 8. So it's what I'm going to do now. It says I'm going to put 8 nodes at a meter of 3 meters apart. And elements on the node, I want constant support. And I click OK. So you can see along the length of the pipe now, I have support at different lengths. So I go to the other side and do the same thing. Right click, insert multiple nodes. So because I've pre-installed some support at the other end, at this point in time, I have those informations on my screen. So I'll just press OK. And I have that. So I'll run analysis again. Yes. And from here, I can now go on to check my output and 3D view. So let me run analysis and see. So my pipe is looking a little bit better, but as you can see, it still have some form of deformation along its length. So we need to fix that. So we are going to fix that. All right. But before we do that, I will just take a short break at this moment and allow you to do what we have done so far. Okay, so I'm going to try to fix my pipeline. All right, so the reason why I'm having that deformation is because of the length of the pipe. So what I'm going to do now is I'm going to reduce the length of the pipe by deleting some pipe section. That is one, or adding another expansion loop towards the length of the pipe. So let me delete these pipe sections. So it says select operation, connect the node to the remaining nodes, then delete piping without combining nodes. So we combine nodes. So we have that. So I go 1, 2, 3. And I right click, delete. So yes, I want you to connect. So that is what I have fits to window. So I have a shorter length of pipe now. So at this point, I run my analysis. Yes. Okay. Then let's go to output, preview, and I can check by playing my dynamic. So you can see that the deformation is not as much as I had it earlier on. So at this point, you can also check the behavior of the pipe while in installation state, in operation state, and in code state. So if you click on installation state, you can see the installation state is the one in green, meaning that when there is no operation between the pipeline, when the pipeline is stationary and just installed. All right. Then the next is operation state, which is what we have. You can see it's going up the support and going up. Okay. Then lastly, we have the code state, which is similar to the operation state. So those are the 3 different states that we have. Okay. So also along the output, you can check a lot of behavior of the pipeline, like the pipe stress. You will see it's all showing code red because this is telling me that this has failed design. Okay. and it has not passed the check for primary load. Also, we have displacement. So constant support, forge elbow, it shows you the displacement of the pipeline while in operation. So between 1 and 2, it is 0. This is because these are the fixed supports. All right. But from point 4 to point 21, you have some form of deflection in the pipe, and which is represented by this distance in meters. Okay. So let's go back to our pipeline. So anytime you see an error code as displayed here, you can click on the help. So our help is the online version that has all the stress code and all the solution to any problem you have in piping. So take for instance, here we have the stress code table. Okay, so it tells us piping stress table giving results for the state for the selected code. All right, so we have all this code applicable to the situation that we are having on the pipe right now. So if I click on B31.1, you are going to see the applicable code here. So a lot of time, maybe when you are designing, somebody can ask you what is the engineering behind this your design, which is what would differentiate you as an engineer from a modeler or someone that just does design without knowing the fundamental principles behind them. So this gives you the fundamental principles behind the design that we are doing. And all this is what Prof has been developed to work with. All these were calculated with hand before, but with Prof, it's just so easy. So this for ASME B31.1 and B31.9. If you click on B31.32, you see the applicable code. Same thing for B31.4 in that order. All right. So this is your one-stop help tool. Anytime you are modeling, the help is just by the side and you can get all the needed information. All right. So what is my pipe analysis telling me? It says failed the stress check for pressure and for load. So let me go down to see. Say failed stress check for pressure and for load. Insufficient thickness. So what can cause failure in stress check? What can cause that? I'm asking. Oh, okay. That is maybe, but there's a principal cause for that has not been said. Have you blown a balloon before? And you keep blowing the balloon. You keep blowing the balloon. It will get to a point. What will happen to the balloon? Why? More than what? So what is that called? What's the engineering word for that? No. Pressure. Excessive pressure. Do you understand? So let us work with that. Now I've clicked on a particular pipe section, which is between node 2 and node 14, the one highlighted in red. And I have my working pressure to be 150 megapascal. The test is 225 megapascal. So let me reduce this to 15. All right. And once you click on a particular pipe section, the dialog box that shows to your left represents the property of that pipe section. and you can make modifications from there. So if I make this one 15 and I make this one 22.5, okay, that is for pipe section between 2 and 14. Then I run analysis again. Yes, run analysis. Okay, this one didn't go. 22.5. Right. All right. So you can see that my node between 2 and 4 is now checked okay. Can you see that? The next one that is bad is this guy, but between node 2 and 14 is now checked okay. Okay, because we have reduced the pressure. So let's do the same thing for 14, node 14 to node 5. Okay, I come here and I make this 15, and I make this 22.5, and I run analysis. Okay, now, so we are having an error because this is the point where we deleted some nodes initially. Remember? But for your own case, you shouldn't have an error at this point. Okay? So try that. So let me do it one by one. So I take these 3 and I change it to 22.5. I run my analysis. So here we have, you can see that above ground between 14 and 13, between 12 and 13, between 8 and 12 have all been cleared. Okay? Yes, we know about the wall thickness too, but we want to take it one after the other. All right? That's why it's showing us insufficient wall thickness. We are aware of that. But apart from that, you can see here that we have, okay, this one is telling us about pipe adjoints to the elements must be of the same property. So now let's work on that. So what I can just do, I can just come here and just a minute. I want to get my elbow. Okay, so we now have a new elbow. Make it a short one. Yes, so we can run analysis now. So the reason why we are getting this error is because we joined the previous node by deleting a pipe section. All right. After now, we are going to model another pipe with shorter length, and this will not come up. But at this point, let's check our output. Okay. Okay, so let me quickly do a new piping. Let's leave that one out. So process piping. Ambient temperature is 23. Service life 20 years. Test temperature, let's make it 35. Okay. Then we'll go to our pipe. Node 1 to node 2, yes. So we have our pipe length along X, 10,000. External diameter, 300. Wall thickness, 15. Corrosion allowance, 2. Pressure, 15. Temperature, 23. Test temperature, that is 30. Let's make it 30. Then insulation. Then work with fluid density, 1000. Apply. So material could not be found. Oh, I didn't set material. So I come here and I pick material and I said, okay. So we have that. All right. So let me cancel, double click on my pipe and make it a little bit longer. So I say 15 and click OK. So we have that. All right. So let's work with this. I add a node at the midpoint. Click on middle. Click OK. We have that node. All right. But I like my units to be in meters. So before I go further, I go on to units, meters, thickness, meters, square per meter, megapascal, inertia, meter raised to power 4, it's Newton, Newton per meter, and I click OK. So you have that. So at that point, I double click. So that is 7.5 meter. I make it 15. I make this 0.4. So this can be 0.5. Then my allowance is 0.01. Click OK. Must be greater than, all right. So let's say this is 2.3. Let's see if that will go. Thickness must be less than, okay, 0.2. Would that pass? No. So 0.02. 0.002. Aha. So we have that. So we repeat the same thing over here on the other side. So we made this 15, right? What was our diameter? Did anybody take notes? Let's quickly check. We can add this before we do that. So somebody should take down this unit. Outer diameter is 0.4. Who is taking it down? Outer diameter 0.4, wall thickness 0.02, and corrosion allowance is 0.002. So we can work with that. Let me reduce my pressure once and for all and make it 45, while this one will be 60. So what did I say my outer diameter is? 0.4. Wall thickness. What was the wall thickness? Ugo, what was my wall thickness? 0.02. Were you following at all? This is 45, while this is 60. So we have that. So at this point, I can click on my node 3 and add my expansion loop. So 2 meters, 2 by 2 by 90. Okay, we have that. Then let me have my anchors on both ends. And the same thing at the other end. Then at this point, I add my bend. Short bend for this exercise. Click OK. Control C. Then we have, click on the points. 1, 2, 3. Control V. So let's run analysis. Save. Yes. We are saving that 310720/4. Yes, continue. Yeah. Okay. So at this point, what are we having? Stress check failed. Stress check failed. Insufficient thickness. So your work as a design engineer is to analyze this pipe, which is the reason why we are having all this in red. And the tool that you're going to use is the help menu, which works with the ASME standard, experience, and also specification from your customer. So since I've run analysis, I can come to my output and say run 3D dynamic and press play so I can see. So the first thing I'm going to do is to do what? What will be the first thing for me to do? Anybody? What will be the first thing I'll do to this pipe? I'm asking. What will be the, why am I adding nodes? Aha. All right, so that is one. After doing that, what will be the next thing I'm going to do again to troubleshoot? If some errors still persist. Mm. Yes, that is two. Yeah, very good. Yes, or even change your material because there is a particular tolerance limit that each material has. So all you have said is correct. And those are all the things that should be on your left hand as a pipe stress design engineer. Because if your pipe should fail in operation just like we are having now, those are the things that should come to you as a quick get. What can I quickly do? So I want all of you to try that on your design right now. Then we'll continue from there in the next 10 minutes. Thank you.